Hello, everyone. Thank you so much for coming here today. We are almost at the end. So thank you so much for joining us. I'm Valentina Rodriguez. I'm a principal architect at Red Hat, but also I'm a project maintainer at Qflow. So at Red Hat, what I do is I build solutions based on OpenShift, from AI, security, developer experience, and yeah, and that's why we are here. Have the pleasure to be with Veda. Do you want to?
Thank you, Valentina. Hi, Veda Shankar, Product Manager at Red Hat on Trusted Software Supply Chain portfolio. And, we have a lot to cover, and thanks for really, coming this late, and we'll make it useful by introducing some of these open source projects that we're working on, which will help you, kind of securing your AI applications and meeting some of the requirements for like EU CRA, right, the Cyber Security Resiliency Act, which kind of mandates that you have model integrity, right, and the models used in your application and overall your application images, they are tamper-proof, or you have, you're securing it. So we'll be talking about tools. So last year when I was here, I introduced our SDLC, the Software Development Lifecycle, and that we use at Red Hat. And we produce quite a few packages, as you know, right? And what are the open source projects that we employ in order to make sure that we are able to build software, I mean, basically any kind of, like image right from the source. And at the same time, we can, with every, say, a Git pull, we're able to, analyze the vulnerabilities. Every build that we do also creates an accurate software bill of materials. And at the same time, we capture the entire build process in an attestation. So that way, we know where it was built, what was the Git source that was used to build it. And at the same time, of course, we create, the artifact signatures, the attestations, and evaluate those attestations using policy as code to make sure that we comply to, compliance, comply to standards like SALSA. So these are, some of the open source projects that we use. On the upper right-hand corner, you'll see Guac, which is, anybody familiar with Guac? Okay, I see a few nods. Awesome. So if you go to, Trustify, you should see oh yeah, right there. So this is, again, trustification.io is our community based on Guac. And at the same time, we also use SIFT to generate the S-bombs. And just to kind of get an idea, like how many of you actually use S-bombs or create S-bombs? Okay, awesome. And then, of course, we use SigStore for signing the artifact and also to create attestations. Anybody familiar with SigStore or use SigStore? Okay. And that's what I was seeing, like a lot of interest in S-bomb generation, but I think the next logical step would be to also make sure, because it's almost like, you take a jar of something from your, your grocery. You look at the ingredient list, but how do you know that the ingredients that are used, so that's your S-bomb, but you also want to make sure that that's not being tampered with, right? So you want to be able to have a signature, have attestation, so that way the actual bottling was done properly, right? That's your build process. And that's why you have the SALSA standards. It gives you different levels of compliance. Now, all this applies to your software development lifecycle, but then your model development lifecycle is not that different. And of course, we are all consuming models from the, from either the Meta or Granite, but then we all know that we need to add some domain-specific knowledge to retrain or create, like basically vector embeddings. So all those principles of, how you want to have more visibility into your security posture is important. You want to make sure that there is integrity of the, say, the vector bindings, the model that you have, downloaded is not compromised as it reaches your final application. And also you want to be able to do it in a way that it's automated. It's easily gets into your pipeline. So that's where the other tool comes into play, which is Conforma, which is policy as code. It's based on Open Policy Agent. And there's also lots of policies. There's also excellent blog. If you go to the blogs site there are some very good blogs which tell you, how to apply a policy and all that. And again, these can be SALSA policies for build provenance, but you can easily tweak it. There's lots of policies based on tests, so that can be changed. We are also now working on some RAG applications and will be coming something more specific to AI. Sorry, I'm rushing through because Valentina has an amazing demo. So why is it important to secure your models and your other AI sets? Because just like an SDLC, you can see you are vulnerable to many types of attacks, even in an AI application, and more so, right? Now, sure, can we use the same signing tools like we use for signing, say, an ISO package? Sure, you can, but a model, as you know, is fairly big. It consists of many layers. And so if you use your standard signing tools, it's not very efficient. It's computationally expensive. There are many times you will be just modifying the weights. You might be retraining. And any such change would require you to resign the whole model. And that's an expensive process. So this is where the SigStore community, and this, again, we had in these meetings like folks from NVIDIA, Microsoft, Red Hat, so they came up with a model transparency library based on Python and for signing AI models. And the whole idea is that you'll be basically capturing all the elements of a model in basically a serialized manifest. And the serialized manifest will contain the path of the individual elements. These are your tokenizers, your weights, all the elements that go into a model. And you'll have a corresponding hash. So that way, when you're going and changing, say, one element, you don't have to recompute the hash for the entire model. And this serialized manifest then is packaged in an in toto format and signed using SigStore and committed into the transparency library. Now, I think one thing I'd like to kind of rewind a little bit, because I've been talking about SigStore because I didn't see too many hands that were raised when I said who is using SigStore. Why is SigStore suddenly making cryptographic signing interesting? Or is because it actually really democratizes the whole signing process. Previously you would sign with, say, private keys, and everybody does it, right? Including Red Hat. We have gold keys, which we finally use to sign, but these are secure. It has to be on a certain laptop. but that it prevented the using signatures and attestations at every stage in the pipeline, right from development along QE, all the way to the final release. What Sigstore did was kind of said, hey, you should be able to use your identity. When I log into Red Hat, I have my identity, veda@redhat.com. I should be able to sign with that. When I'm running a pipeline, that pipeline has an identity based on the system it's running on. And the pipeline has an identity, and you should be able to sign using that identity. And that's because it supports OIDC Connect. So you can get an OIDC token, use that for signing it. So your trust is on that identity provider. That could be a Google, it could be a GitHub, it could be your enterprise's single sign-on or Entra ID, right? And sorry? Yes, because you could have your GitLab sign it, but then when you say trust, in the sense, the other end, you could have a policy that says, hey, if it is signed by Red Hat, the production pipeline, then I will accept it. So, it's no different than saying I will accept something signed by a certain, PKI key, right? But then it's so much more easier, right? Now I don't have to store those keys, because what Sigstore does is uses that identity of, say, that GitLab, creates a temporary certificate, signs the artifact, and then destroys the private key. So that way, there is no question of getting compromised. All you need is the public key to kind of confirm the actual person or the service account that was used to sign. Now, in addition to that, there's also a transparency log. So the whole signing event is logged into a transparency log. And this transparency log can be kind of referred to. You can even take a snapshot of that and then transfer into an air-gapped environment, so that way you can verify it even without access to the Sigstore instance, right? Okay, how much time do I have? I need to, I'll give it, yeah. Okay, so, okay, can you see it? All right. I just wanted to quickly recap. So over here, you can see a Granite model. So if I do an ls on the Granite model, you'll see that it has, the model files, and then of course the tokenizers and all that. And I've created a model.sig using Sigstore, and Valentina will show you how to do it. But essentially, if you look at the model.sig, you will notice that there is an envelope. Basically, this is the envelope which has all the serialized manifest. And the whole thing is packaged in an in-toto format. But you'll also notice that there is a transaction log entry here, right? Now, you can also look at the actual envelope, and you'll see that this is what, it has all these different parts of the model and their corresponding digest. I think it's a good segue now for me to hand it over to you.
Thank you. No, thank you, Veda, for, we have this next.
Oh, yeah, you can.
Skip it?
You want me to?
Oh, you let me know.
It's okay, I think we're running short of time. So.
Okay. So, so we talk about the different concepts and the importance of model signing. So I want to show you how I have a demo that will show you different steps. So we'll start with the command line. We will sign the model using the transparency project from Sigstore. And then we will start evolving into GitHub Actions and all the way into an enterprise environment using different projects such as Backstage and Qflow and Argo CD. So it will become more interesting every second. So I will start with this. Sorry, well, back to the slide. Yeah. And then let me sum in. So here what I'm doing, I'm the terminal. I am using a container image to run and using the Sigstore library, the model transparency. And with that, what I'm providing is I'm providing a specific folder, but also I'm providing the folder where the model will live and the folder where my signature will store. So in this command, and I'm not providing an OEDC token, but this, if I am not providing one, Sigstore will provide one for me. So I can use an identity provider. In this case, I use GitHub, and that is returning a code that I can use to verify my persona. So it creates and do an authentication behind the scenes, and that is signing the model. So it says sign and succeed, and it will be creating the model sign within that specific directory. So next, what we will see, so this is within the terminal. This is all provided by Sigstore. I customized it. You could do the same. These examples are online, so you can play around with the terminal. I customize it through my own user and folder specification. And here, what you can do is moving into a more automation approach using GitHub Actions. So this is a workflow that what it's doing, it's also signing that model with the Sigstore model transparency key, but it's getting the OEDC token from my user. So I am here passing the OEDC token. So in this specific file, and also after this, it will be creating a tar file and it will be uploading. So in this case, I'm showing that workflow already run. It created that specific file, so I can download it. So with this, let me go back. So now what I want to show you is once we sign that model, we need something to validate that model. So, and then I will go back to this slide. So the model, I want to introduce you to the model validation operator, which is part of Sigstore, and Red Hat contributed to this. This is what it will be validating, is that model was signed before it will run on the cluster. But not only that was signed, it will also validating according to your rules, your identity provider, your issuer, is that model is who it says it should be. So that is great, but also I can do it in different namespaces. I can specify a name. So we'll show you how to do that. But in the way that it works is once I install the operator, that's something that you can do through the Sigstore repository. There's plenty of examples how to install the operator. You can install it on any Kubernetes platform. So you will install the operator and you will create an object that is called a custom resource that is called the model validation. In that object is where you will do your specifications about when that model is valid or not. Once you create that object and you sign the model, and that model is mounted into a pod as a PVC, that pod will have a specific label. Then the model validation controller, what it will do, it will look for that pod and it will be verified against that custom resource. Once it's verified and if it's okay, it's green, yes, it will run on the cluster. If it's not, it will not run on the cluster, which is what we want. So now going back to the demo, how this will work. I want to show you here, so this is where we left. back. Okay, so here is, I am in a Red Hat OpenShift cluster, which is an enterprise version of Kubernetes from Red Hat, but this can be done on any Kubernetes. So here I have two different model validations that are running on different namespaces, it has different names, and it has different configurations. So we'll play with both of them, and I will show you also how to create one. So once you start creating one, it will be having like the API version from Sigstore, the kind is model validation, and then you can specify the name, you will specify the certified identity, and then the issuer. So here I'm using the GitHub actions that I previously showed you. It's with my user, I forked the repository, so it's using those specific credentials to validate the model. The other thing that I'm saying is where to find the model and where to find the signature. So with that, I am done. I can just create the object, that's it. So but what is next? Now I want to deploy that model. So in this example, the model is signed, so it will show it was running, as we can see. But also I want to show you how you make this validation possible. So when I show you the slide, I mentioned a label, and this is the label that we include on the pod. So it's a validation label, ML Sigstore, and then I can specify the name from the model validation. So this will be connected to a specific configuration, so which is great. So I can have multiple configurations on my cluster. Once I have that, I also have using the PVC with a specific path. So I'm showing there, so the volume that I'm using with the model is the same that I define on the model validation. So now I can see the verification succeeded. The other thing I want to point out, as you can see here, we have a new container running on the pod. So that is the one that is doing the validation before the actual container from the model will run on the cluster. So with that, I want to show you, this looks great, right? We signed the model on the terminal, we did GitHub actions, and then we validated the model on a Kubernetes platform. Perfect. But you probably don't want to deploy your model as a pod, right? You probably want to run it through a platform such as Kubeflow, which is an AI ML platform. It's a project that is part of the CNCF. So you may want to do that at scale. But what else we can do? So because we work with developers and I want to build a chatbot, I want to work with internal developer portals. So this is a product from Red Hat that is called Developer Hub, which is based on Backstage. So we'll refer about Backstage because this is something you can do with Backstage. Backstage basically is that singular place that you can build different platforms based on golden templates for developers to access, build, and deploy applications. So we will do exactly that. I'm using someone else's computer, so sorry about that. Of the person. Let me go back to the, okay, here we are. Okay, so I already created a chatbot. And what this means is this chatbot is already running on the cluster. It's been deployed with all the security constraints and so on. But the other thing is being deployed with a large language model on the cluster as well. So we will play a little with the chatbot. We will see that it's running and it's working. Looks great. So that is fantastic. But what if I decide to deploy a model that is not signed on the cluster? So what will happen? So I want to show you, before we go into that, what happened behind the internal developer portal is Argo CD. How many of you are familiar with Argo? Yes. So it's all GitOps. What it's doing is it's reading all the configurations from all those golden templates that are stored on a Git repository. It's looking into that as a source of truth and it's ensuring that that true is also true on the cluster. So it's always looking for the desired state, it's always the actual state. So those are all the objects that are being created through Backstage. And now I want to add I want to deploy that model that is not signed. So here are all the different manifests. I will go into the AI folder, and I will create a new inference service, which is part of the Kubeflow platform. So what I will do is just add in the name here and sign, and then I need to add that label that is connecting to a specific model validation. So now I am checking the model. So because we have two, remember, we have two model validations, so I want to pick the other one. And then here I'm looking at the name, so I'm copying the name to ensure that I'm using this one. And this one, the change is in a different namespace, but it's also pointing into a different path, because this model will live in a different path within the pod. So right now, but just adding the name to the file. But as you can see, the API version is from Serving Kserve, and the kind is an inference service. So what this will do, remember the name is unsigned. This will be created through Argo CD. So I am forcing here Argo CD to do a refresh and read from the Git repository the latest changes, and it's been read, it created, now the screen, it means it's on the cluster. And now, this will not create the pod. It's actually creating the deployment object, which is creating a replica set, which is now creating the pod. So it's a robust solution for deploying models. We can see here from the cluster that specific object, which is a Granite model that I'm deploying. This is the deployment object, and here I can see the pod. So the pod is running, it's not running. It says initialize. And then I can see here I have two containers, and one is the container model validation. That is the new container that is doing the validation. And it's saying, well, no, you don't have a model signed, so it failed. So you cannot run. And then the chatbot will not run. So, which is good. Of course, you can add different measures in order to ensure that that doesn't get, loading, but it's safe. It shows how you can securely ensure that a model that is not signed, it doesn't run on the cluster. With that, I want to show you some resources. So from Kubeflow website, there are a lot of information about the community meetings and how to contribute. From Backstage, there is also talk. But of course, about Sigstore, there are a lot of different blogs and also the work that we are doing at Red Hat. And if you want to connect with us, there is also this information here. But also, we will be around a few minutes if you have any questions.